Hey guys, Mr. Wilson here. Today we're going to talk about writing function rules. At the end of this video, you should be able to identify the pattern to get from the domain to the range, and you should be able to write a function rule from a table or situation. Okay, in this lesson we're going to work backwards from what we've done so far. Instead of giving you the function rule and having you create a table or find the range, you're going to create the function rule or find the function rule. Okay, in the following tables, identify the pattern that gets you from the domain to the range. Okay, so domain, remember that's just another way for us to say the x value, to the range, y values. So when we say domain, because we're talking about all the x values, we're not talking about just from one x to the next, or from one x to one y, we're saying from something that works for everything. Okay, then use the pattern to write the function rule. So what we're going to do is we are going to look at each of these values, and really I like to look at it kind of isolated. I'm going to look at this and say, how do I get from 0 to 3? What mathematical operation am I doing to get from 0 to 3? Okay, and so when I look at that, I say, okay, I'm adding 3. First thing I think of. Okay, if that works, then I move on to the next thing. I say, does that work for the next x value to its y value? So if I add 3 to 2, I get 5. Okay, that works for 2. See if it doesn't work for the next one. If I add 3 to 4, I get 7. 3 to 6, I get 9. So my pattern is add 3. Okay, or you can say plus 3 either way. I don't really care there. But remember that, well, not remember because I haven't told you yet, but that it doesn't end there. Okay, the pattern is not the function rule. The function rule tells me kind of the equation that I can use to make my table forever. And so here's the function rule. I can say I get to f of x, or f of x equals, because I said I'm adding 3, to x. So f of x equals x plus 3. And so just like our last lesson where we were evaluating functions, now we're making that rule to be able to evaluate functions. Okay? So we identify the pattern, then we see the function rule. Alright? So looking at the second problem, I'm going to do that same thing. And here if I look at 0, 0, there's just so many things that can happen to get from 0 to 0. You could be adding 0, subtracting 0. Well, doesn't really mean anything. You could be squaring something, multiplying by something, dividing by something. So really, we won't take too long to look at 0, 0. Now we have 1, negative 4. Okay, how do I get from 1 to negative 4? Well, I have two options that I can think of right now. I could either be multiplying by negative 4, or I could be subtracting 5. Okay, so I'm looking at both of those options saying, okay, which of these works? To get from 2 to negative 8, I'm multiplying by negative 4. Okay, so that seems like, okay, let's say, subtracting 5 definitely doesn't work for this. Multiplying by negative 4 did. Negative 3 to 12, multiplying by negative 4 works. Okay, and so now I've identified my pattern. I'm going to multiply by negative 4. And now as I write my function rule, I'm going to say, okay, well my pattern is that I'm multiplying by negative 4, so my function rule is y equals negative 4x. Alright? I'd like you to find the pattern and the function rule for this table number 3. Number 4, looking at this, okay, we have that same kind of approach. We say, okay, 0 to 15. How do I get from 0 to 15? Okay, okay, I could say I'm adding 15 each time. How do I get from 5 to 10? And now this is a little bit different because we're like 5 to 10, that's adding 5. That's different from the first one, so it doesn't work out that way. From 10 to 5, again, now we're subtracting 5. From 14 to 1, we're subtracting 13. Okay, so the adding, multiplying things aren't necessarily going to work. So we have to kind of look at this in a different way. Okay, what do we notice? Okay, well, the thing that I noticed about this is that all of these, when they add up to each other, equals 15. Okay, so they always have to add up to 15. So really, I can think of this as saying y, or f of x, let me say that my pattern is sum is 15. So f of x really is just what's left of 15, because whatever it is it's what's left of 15 after you take away x. And so it kind of gives me my function rule that f of x is 15 minus x. Because when 15 minus 0, f of x was 15. 15 minus 5, it was 10. 15 minus 10, it was 5. 15 minus 14, it was 1. Okay, so sometimes you can do, hey, this is how I get from x to y, and sometimes there's just other patterns you have to look at. Alright, so in problem number 4, what is f of 20? Okay, and this is how we can use our function rules as we've been evaluating them before. Well, now we can say, okay, well, f of 20, what I do is I plug in 20 for x. And so if x was 20, 15 minus 20 is negative 5. So f of 20 is negative 5. And I should probably write that here. F of 20 equals negative 5. And so that function rule really allows us to plug in any value that we want and simplify it. Alright. Here it says what is the x value when f of x equals 3? Okay, so still looking at number 4. Now this is what we're going to do here. They tell us f of x is 3, and so what we can do now is say, okay, we know this part of the equation. It's 3. Make sure I'm writing someplace where I have space. Okay, 3 equals 15 minus x. So notice here now that they told us, hey, f of x is 3, we're substituting that in, and now we can just solve for x. So we can subtract 15 from both sides. That will give us negative 12 equals negative x. And so that means x would equal 12. Alright, so kind of setting up an algebra problem for ourselves there. Flipping to the back side, we looked at tables, and now we can look at situations. We'll set some of these situations up, and then I'll have you guys finish these and talk about them in class. Alright, so we're going to write a function rule with situations. A cup of frozen yogurt at Yo-Yo costs 49 cents per ounce. Write a function rule to determine the final cost, C of n, of buying n ounces of frozen yogurt. Okay, so here's what we can do. We know that for each ounce, we're going to get charged 49 cents. So C of n, the cost of the ounces, equals 0.49 per ounce. So in our calculations then, it says write how much a cup that weighs 8 ounces would cost. And so we can do C of 8 equals 0.49 times 8. And so 0.49 times 8 give us $3.92. So C of 8, $3.92. C says, how many ounces could you buy with $6? So again, now we're given the total. And so I'm going to use 6 on this side. The other side of my function I know is 0.49 n. And so now I need to solve for n. In order to get n by itself, I need to divide both sides by 0.49. Calculator would be helpful in this case. 6 divided by 0.49. And that gives us 12.24. Okay. And I'm going to leave it there. That's how many ounces I can buy. probably 12.2. Okay, so I could buy 12.2 ounces. All right, so with that, we are going to set up these next two, and then you'll bring the answers to the following questions with you. So number 2 says, to rent a hot air balloon, it costs $200 plus $21 per hour. Write a function rule to determine the final cost of renting a hot air balloon. So the cost of a hot air balloon, that's just the name that we used here, is $200 no matter what, plus $21 per hour. So H. Okay, so here's our function rule, and now we're just answering questions based off of that information. So bring these answered questions to class done for me. And number 3 says, write a function rule to determine the change you would get from a $20 bill when purchasing items that cost $1.25. Okay, so again, this is how money works. The change from 20, so I'm going to name it like this, C of 20, equals something. Okay, bring that to class done. Okay, we'll talk about both of these problems to class. I want to give you a chance to think on this and see how you came up. Okay? All right. So, looking at this, we should know how to write the function rule given a table, and we should be able to write the function rule given a situation. See you guys.